Okay, good evening, everybody. Today's our first flipped classroom of the year, and what you're going to do is you're going to copy down the notes that I'm giving, and then you can pause, rewind as needed to make sure that you're getting everything, and then it's a great idea to write down some of the stuff that I'm saying so that your notes will make sense. And then on Wednesday, we will come back together, discuss the notes in case there was anything that was confusing, or if I happen to make a mistake. All right, so the first thing we're talking about today is similar figures, and so basically, similar figures are considered similar if they have the same shape, and right off the bat, I mean same, not shame, the same shape but different sizes. Okay, so the same shape but different sizes, and then that we consider those to be similar shapes. The other way you can look at it is by looking at their angles. If two shapes have the same angles, then they are similar. So there's two different ways. One is kind of simple, I mean the same shape but different sizes, and then one is if they have the same angles, then they are similar. Okay, so there we go. There's a little basic definition of what similar figures are. Now we're going to take a look at using some of them. Okay, so here we have two shapes, and we can tell that they are similar because this angle here is the same as this angle here, and this angle here is the same as this angle here, and lastly this angle is the same as that angle. Okay, so once you have that, then the corresponding sides are in what's called a proportion. So when we look at proportionality, we can set up a proportion to see that the sides are equal. So what I have here is I see that this side is in this, whoops, I didn't mean to do that, that this side here is in the same position as this side here. Therefore, those correspond. So I can say 8 over 6. And that's going to be equal to this side here over this side here. So that would be equal to 10 over x. Now, when you do this, when you set up your proportions, one of the main things that I emphasize for my students is that they have to keep the position the same. And what I mean by that is I put the big triangle over the small triangle. So if we look at this, 8 came from my big triangle, 10 came from my big triangle, 6 came from my small triangle, and x came from my small triangle. So I did big over small, and then I just had the sides correspond. Now, the last thing that I do that's a little bit different than a lot of teachers is the way you solve this proportion. A lot of teachers have students circle like this and circle like this, and they use the words cross multiply. I don't mind the words cross multiply, I just don't like that circle because it shows no direction. So what I have my students do is I have them circle the bottom and they draw an arrow. And they circle the bottom and they draw an arrow. And then they need to follow the arrows because that shows direction. So that means on the left hand side I would have 8x, and the right hand side I have 60, and then the last step is to divide both sides by 8. So I get x is equal to, and then I don't care if you simplify that or not, whatever you want to do, 7.5 is fine. Okay, so that's one of them. The other proportion that we could set up would be for this side right here. Whoops, there we go. This side right here, this green side corresponds with that green side. So I can set up another proportion for that bottom one, and it doesn't matter. This time I'm going to do small over big. So I'm going to do 15 over y. That is the small one over the big one. And that's equal to, and it doesn't matter, I'm just going to go ahead and use the blue side. I got to make sure that I put the small over the big. So there we go. So I have 6 over 8, like that. And then once I have that, now I can do my cross multiplying. So I circle an arrow, circle and arrow. And so I get 8 times 15, which is 120, which is equal to 6y. And then my last step is to divide both sides by 6, and I get y is equal to 20. Okay, so we can talk more about that cross multiplying, why I like it that way, but I don't want to spend too much time on setting up the proportions and solving it. Okay, let's take a look at the next type problem. Okay, so here's another similar figure. Notice that we're spending a lot of time with triangles because we use triangles a lot, but this is called an embedded triangles, and embedded triangles are automatically going to be similar because of they guarantee that we have that's weird. I don't know what to do now. That we have angles that are the same. So first of all, we have to know that this is parallel to this. Okay, so AB is parallel to DE. If AB and DE are not parallel, then we can't say anything about it. But if AB and DE are parallel, then we can say that these are going to be similar shapes, or excuse me, similar figures. So what we have is I don't know why. Okay, sorry for that little interruption there. I'm having some weird things happen with my iPad, but so anyways, so we can say that, I don't know if you guys see this thing clicking here. Oh no. Okay, sorry. I hope I got it fixed now. I don't think I do, but I'm going to try and keep going. Okay, so now what we're going to take a look at here is we have this side. Excuse me, no we don't. We have this angle here is the same as that angle there. Okay, that's good enough. We have this angle here is congruent to that angle there. That's good. So we have two of our three angles that we know are congruent because they are telling us by their markings. The third angle is the one that students don't see very well, and it's what's called the embedded angle. This embedded angle right here is the same for DCE. It's for that part of the triangle, and it's also for ADB, or excuse me, ACB. So the embedded angle counts for both the big triangle and the small triangle. Once I see that I have that, then I know that I have two triangles that are congruent. And then I can set up my same proportions. So the question here is for me to find DE, so that's this distance here, and they give me AB, and they give me DC, and they give me, they give me AD, and they give me DC. So they want me to find DE. Okay, so I'm going to set that up right now. So I'm going to be trying to find this angle here, or this side and this side. So I'm going to go ahead and put the small over the big on this one. So that's X. I don't know what DE is, so I'm going to say X over, and then they tell me that AB is 10. So X over 10 is equal to, and then what they tell me is they tell me that AD from here to here is 8. And they tell me DC from here to here is 6. Well, that means that the side that I care about is this entire side all the way across, which is 8 plus 6, or 14. So this side here is 14, and that's the big side. So that's going to go on the bottom, 14 over, and then the small side that corresponds with that one is right there. So that's my small side. Okay, so then I can put on the 6 on top like that, and then I have my proportion set up. I can circle an arrow, and circle an arrow. So I get 14x is equal to 60. Divide both sides by 14. And I get x is equal to, and again, I don't really care. If you figure out how many times that goes in there, you could just simplify it down to 30 over 7, or 4 2/7. Okay, so that means that x right here is equal to 4 2/7. Okay, that's embedded triangles. Let's take a look at the next slide. Okay, the next slide is a word problem. This is where it becomes most useful. The first few is just kind of learning how to use proportions with similar triangles. This is where we actually start to see how we could use it in solving a problem. So the problem says a flagpole casts a 20-foot shadow on the ground. A 6-foot tall man casts an 8-foot shadow. How high is the flagpole? Alright, so the first thing I'm going to do is I'm going to go ahead and draw my flagpole. It goes something like this. And the shadow goes out like that. And I'll say there's my flag, and there's my flag. Okay, so I don't know what this height is. That's what we're trying to figure out. But I know that from here to here is 20 feet. It's a 20-foot shadow. Okay, now the next one, or next info that they gave me was there's a dude standing here. There he is. Call him a little Martian. And he casts a shadow, and that shadow from here to here, it tells me, is 8 feet. And then they also tell me that his height is 6 feet. Okay, now the question is, are these two things, these two shapes similar? Well, if we look at it, we could say that the sun must be over here somewhere, and it's beaming down at an angle like that, and the angle to which it is beaming is the same, minus that little scribble right there in the middle, but it's the same angle coming from the sun that's being cast on these two shadows, assuming that's the same time of day. So, okay, so then we know that then this angle is going to be the same as this angle. That's kind of good. But what else do we know? Well, if the pole is in the ground and the person is standing on the ground, we assume that the people putting the flagpole in didn't put it at an angle. They put it straight up and down, which means this would be a right angle. And we assume that this person is not leaning over, not staggering home from the bar or something and leaning to one side, and so he's standing at a right angle. Well, then if we know that this angle is the same as this angle, and these are both right angles, then that means that this third angle must be congruent, because we know that triangles are 180. So even though I don't know what that angle is over here, I know that this angle has got to be equal to that angle. Therefore, we know that these are similar figures, and then we can set up our proportion. So the proportion I'm going to set up is going to be, it's going to be big over small for this one. And so my first big side is going to be the blue one here. So that's x over this man's height, which is 6, and that's going to be equal to the shadow, which is 20, that's the big shadow, over the person's shadow, like that, and that was 8. And now I have my proportion set up. I circle an arrow, circle an arrow, so I get 8x is equal to 120. Divide both sides by 8, and I get x is equal to, 15. So that means the flagpole must be 15 feet high. Okay, so that's how you use it in a real world problem. We'll look at some other examples in class. And then the last slide. Okay, so here we have some points that are given, and we have a graph set up here, and the points are 4, 3, for point A, 8, 6 for point B, and we're starting at the origin, which is 0, 0, and they say the distance from A to C is 5, and they want you to find the distance from A to B. Okay, so I'm going to go ahead and plot these points to begin with. So AB is 4, 3, so that's about right there. That's A, and then 8, 6 is B. There's 8, and there is 6, right about there. That's B. So they tell me that from here to here, that is, oh, and this is point C here. The origin is point C. So from A to C is 5. A to C is 5. And they want you to tell me how far it is from A to B. This is my X. We don't know what that one is. So it looks like it's about double, and that seems like kind of makes sense, but we don't want to make an estimate or a guess. We should be able to calculate this. So what we can do here is the same thing that we were doing before, is creating triangles, and this one in fact is going to be embedded triangles. So what I can do is from point A, drop it straight down, just like that. And then from point B, I can drop it straight down. Now, the question is, are these embedded triangles, are they similar? Well, if I drop this one straight down, that means it went at a right angle. If I drop this one straight down, that means it went at a right angle. So those two angles are the same. We talked earlier how embedded triangles have angles that are shared, therefore they must be the same. So that means that the other two angles have got to be congruent to each other, because that's all that's left. So yes, these two embedded triangles are the same, even though I was never told that this line was parallel with this one. If I dropped it straight down vertically, then it would have to be at a 90-degree angle, therefore they are parallel. Okay, so then how does that help us? Well, I know that the distance from here to here must be the height that I went up. So that makes that one 3. Whoops. Okay, so what I know then that is this side here is the same height that I had moved up when I plotted my point. Therefore, it must be 3. And then this base here has to be 4. So there's the dimensions of a triangle. All right, I'm cool with that. And then I see that over here I have a height of 6. That's from here to here. And then some might go, oh, you've got 1, 2, 3, 4 more, which is an interesting thing. So that distance is 4, but I don't need the distance from here to here. I need the distance from here to here. So that 4 plus this 4 gives me a total of 8 for that one. Then I can set up my proportion. Okay, so what I notice here is that I have the side that I'm interested in is from there to there. That's the side I'm trying to get. This is part of that side, but I don't have a proportion that I can set up that gives me just this. I've got to do the whole side. So what I'm going to do is I'm going to do big over small once again, big over small. And I'll use my height, I guess, for no other reason. I'll just do the height. So the height of the small and the height of the big, so it's going to be 6 over 3 is equal to, and then the easy part is the angled part of my small, that's 5, and then the angled part of my big goes all the way across here. Well, it's not x, and it's not 5, it's 5 plus x. So on top here I have 5 plus x. And that's my proportion that I'm going to set up. So now I can cross multiply like that and like that. And here we have to make sure that we do our cross multiplying correctly. So I get 15 is equal to 3 times 5 plus x, and you got to make sure you put the parentheses around the 5 plus x. So that is, excuse me, that's not 15, that should have been 30. Right here. Sorry, I'm catching all my mistakes, won't be any fun. So 30 is equal to 3 times 15, or 5 plus x. So then I get 30 equals 15 plus 3x. I'm going to go ahead and finish that over there. So then I subtract 15 from both sides, and I get 15 equals 3x, and then divide both sides by 3, and x is equal to 5. So this distance here is 5. But the question was, how far is it from A to B? So from A to B, it's all the way across. So the answer then, AB equals 10. Okay, so now's a good point for me to take a look and point this out. If you just copy down what I wrote down, look at the mess that's on my board right now. If you don't have some additional notes that go along with it, the things that I'm saying, this might not make a whole lot of sense to you, which is why you have to write down stuff that I'm saying as well as the stuff that I'm writing down. Okay, so what I'd like for you to do is I'd like you to try and fold and solve these 5 or 4 problems really, and see how you do on fold and solving them, and then we will discuss them and the notes on Wednesday, and if I happen to have made any mistakes that I didn't catch, please make sure we get that pointed out so that nobody's confused. All right, have a great rest of your weekend. See you on Wednesday.